In this video, I'm going to talk about relative motion. Consider this scenario. We have two moving cars. The first one is a red car. Let's call it R. It's moving with a velocity of 80 kilometers per hour to the right. Second car is a blue car just behind. It's just behind this red car. It's moving to the right as well with a velocity of 120 kilometers per hour. This blue car would gradually overtake red car because it has a higher velocity. Let's say a person is watching the motion of these cars from the ground. He is not moving. So let's call this person G. Okay, ground. Yeah. So according to this guy, this blue car is moving with a velocity of 120 kilometers per hour. So how do you write that? Velocity of blue car with respect to ground is equal to 120 kilometers per hour. The velocity of a red car with respect to this guy on the ground, with respect to the ground, is 80 kilometers per hour. Let's say a passenger inside this red car, he is watching the motion of the blue car. He wouldn't feel like blue car is moving with 120 kilometers per hour. He would feel like it's slowly overtaking him, right? How do you write that? Velocity of blue car with respect to someone inside the red car, velocity of blue car with respect to red car is equal to velocity of blue car minus velocity of red car. VB means velocity of blue car with respect to ground, and VR, this is VB, and VR means velocity of red car with respect to ground, VR. So that's how you find the velocity of blue car with respect to red car. Let's find the answer. VBR equals velocity of blue car with respect to ground is 120 kilometers per hour. 120 minus velocity of red car with respect to ground is 80 kilometers per hour minus 80. The answer is 40 kilometers per hour. This answer means if you are inside the red car and you are watching the motion of the blue car, you would feel like the blue car is moving with a velocity of 40 kilometers per hour. Now imagine another person inside the blue car. Okay, he's watching the motion of the red car. We are finding the velocity of red car with respect to a person inside the blue car, or with respect to blue car. So VRB. So how do you write the equation? VRB equals VR minus VB. VR is the velocity of red car with respect to ground, and VB is velocity of blue car with respect to ground. Okay, so VR is 80 and VB is 120. 80 minus 120 is minus 40 kilometers per hour. Okay, think about this negative sign. For this guy, he would feel like the red car is moving backwards, right? It's slowly moving backwards. He wouldn't feel like the red car is moving at 80 kilometers per hour towards right, but he would feel like the red car is slowly moving backwards with a velocity of 40 kilometers per hour. That's the significance of this negative sign. Let's consider two objects, object A and object B. And let's say object A is watching the motion of object B. So A is the reference frame. A is the reference frame. Reference frame. And B is the object. So velocity of B with respect to A is equal to velocity of B minus velocity of A, where B is the object and A is the reference frame. So that's how you write the equation of VBA. Now what if B is watching the motion of A? Then B is the reference frame and A is the object. So how do you write the equation for that? Velocity of A, object A, with respect to B, reference frame B, is equal to velocity of A minus velocity of B. Keep this in mind. If I write just VB, that means velocity of B with respect to ground, or you could also call it lab frame. I'm going to modify this equation a bit. And let's say we have three things: object O, moving reference frame M, capital M, and ground, capital G. Okay, so velocity of object, which is O, velocity of object O with respect to the reference frame, in our case moving reference frame, it's M, so VOM equals velocity of object, which is VO, minus velocity of the reference frame, moving reference frame, VM. VO means velocity of object with respect to ground, and VM means velocity of moving reference frame with respect to ground. These are all vectors. So that's our general equation for relative motion. How do you write the equation for VOG, or velocity of object with respect to ground? Rearrange this equation. VOG equals a vector VOM plus vector VMG. Okay, so that's our main equation for relative motion. VOG equals VOM plus VMG, where VOG is velocity of object with respect to ground. VOM is velocity of object with respect to moving reference frame, and VMG is velocity of moving reference frame with respect to ground. Ground reference frame is also called lab reference frame, lab L. So I'm going to modify this equation one more time. Yeah, same equation, just replacing G with L. So VOL, velocity of object with respect to lab frame, which is same as ground. So velocity of OG, velocity of OL here, equals velocity of object with respect to moving reference frame plus velocity of moving reference frame with respect to the lab frame. Another form of the same equation. These are all vectors, right? So let's draw vectors. This is VOM, vector VOM. This is vector VML. To find VOL, I'm going to take this vector, I'm going to place it here. Now two vectors are back to back, tail, head, tail, head. A VOL should be the resultant of these two vectors. So how do you draw VOL? From the starting point all the way to the ending point. That's VOL. So I've been talking about reference frames, right? So what is a reference frame and why do we need a reference frame? I'll try to explain that. Consider a moving bus. This bus is moving with a velocity of 20 meters per second to the right. A person is sitting in the bus, right? Let's call him person A. Related to the bus, he is not moving, so his velocity is also 20 meters per second. Now another guy is walking. He's walking at a velocity of 2 meters per second with respect to A. From the perspective of A, B is moving with a velocity of 2 meters per second. There is one more person. He's standing on the ground. He's not moving. He's just standing on the ground. He's watching the motion of this bus. Let's call him G. He's standing on the ground. In this scenario, who is the object? Person B is the object. He is moving inside a moving reference frame. And what is the moving reference frame? This bus. Or you could call person A as the moving reference frame because he is moving with the same velocity as that of the bus. So he is the moving reference frame. moving reference frame, and this guy is the ground. So in simple words, a reference frame is like a coordinate system from which we are observing or measuring the motion of an object. So if you are considering ground as the reference frame, okay, this is my reference frame, ground reference frame, and this whole bus is moving, right? Now, if you're considering the bus as the reference frame, like a moving reference frame, if you're watching the motion from the bus, then you would feel like person A is not moving, person B is moving with a velocity of 2 meters per second, and this guy on the ground, he's moving backwards. Okay, I'm going to find the velocity of person B with respect to ground. Our equation is velocity of object with respect to moving reference frame is equal to velocity of object with respect to ground minus velocity of moving reference frame with respect to ground. What is velocity of object with respect to moving reference frame? Our object is person B and moving reference frame is this bus or this person A. Both of them are inside the bus. A is not moving, but B is moving. For person A, he would feel like B is moving with a velocity of 2 meters per second. So velocity of object with respect to moving reference frame is 2 meters per second. And what is VOG? Velocity of object or velocity of person B with respect to this guy standing on the ground. That is VOG. We are going to find that. We don't know. We're going to find that. What about VMG, velocity of moving reference frame with respect to ground? So according to this guy, bus is moving 20 meters per second. So is this guy, person A, right? So velocity of moving reference frame with respect to ground is 20 meters per second. Substitute all the values in the main equation. VOM is 2, VOG we don't know, we are going to find that, minus 20, VMG is 20 meters per second. VOG equals 20 plus 2, that is 22 meters per second. VOG is 22 meters per second, or velocity of object with respect to ground reference frame is 22 meters per second, or velocity of person B with respect to person G is 22 meters per second. So, velocity appears different from the perspective of observers moving at different velocities, or velocity is relative, or motion is relative. That is relative motion. Okay, let's do a problem now. You are walking on a moving walkway in an airport. The length of the walkway is 59.1 meter. If your velocity relative to the walkway is 2.35 meter per second and the walkway moves with a velocity of 1.77 meter per second, how long will it take you to reach the other end of the walkway? I'll draw this picture. So walkway is the moving reference frame, right? It's the moving reference frame. You are moving on a moving reference frame, so you are the object. And you are walking with a velocity of 2.35 with respect to the walkway. So velocity of object with respect to moving reference frame, walkway is the moving reference frame, right? Velocity, your velocity related to walkway, you are the object and walkway is the moving reference frame. So velocity of object with respect to moving reference frame is 2.35 meter per second. The walkway moves with a velocity of 1.77 meter per second. Velocity of walkway or moving reference frame is 1.77 meter per second with respect to, if I write just VM, that means VMG. Velocity of moving reference frame with respect to ground is 1.77 meter per second. How long will it take you to reach the other end of the walkway? So we need to find the time, right? This is the starting point. This is the ending point. This distance is 59.1 meters. We need to find the time. We can use the equation for velocity. Velocity is displacement over time. Time equals displacement over velocity, or displacement over velocity of object with respect to ground, the actual velocity of the object, right? Or VOG. That's the equation for time. Okay, we have distance, which is 59.1 meters, but we don't have V or G, right? I'm going to find V or G. What's our equation for relative motion? Velocity of object with respect to moving reference frame is equal to velocity of object with respect to ground minus velocity of moving reference frame with respect to ground. What is VOM? 2.35. Velocity of object, your velocity with respect to moving reference frame is 2.35. VOG is unknown, we're going to find that, minus velocity of moving reference frame with respect to ground. Velocity of walkway is 1.77 meter per second. So VOG equals, rearrange the equation, 2.35 plus 1.77, 4.12 meter per second. Now we can find time. Equation for time is distance over velocity, or in this case velocity of the object with respect to ground, V or G. Distance is 59.1 over 4.12, 14.3 seconds.